Okay, so yeah, thank you everyone for joining so far. Yeah, looking forward to this webinar this morning, and yeah, let's get the show on the road. So just to let you know, we will record this webinar, and we will send on the slides and the recording over the next couple of days to you, so you have that for your future reference. Just a little bit, very briefly about myself. My name is Fiona Motherway. I'm a product specialist here at Fivetran, based in the Dublin EMEA office. And if you're not too familiar with Fivetran, Fivetran is an extremely efficient way to replicate data into your warehouse. We have built zero configuration, zero maintenance connectors that connect to your sources, so your database, your events, your applications, your files, and we load that data into one central location. So for example, your Snowflake. So I think we're all about enabling analysts to do their work, empowering business users through a tool such as Looker. We probably have, I would say, 100 plus mutual clients with both Looker and Snowflake, so we are very closely aligned and very close partners. So yeah, I'll just run through some brief introductions, and we can start probably with Nathaniel Spahn of Fivetran.
Hello, everyone. I'm the director of Fivetran here in EMEA, and I'll be on the panel to answer any sort of very technical questions at the end of the discussion. And I'm really looking forward to this presentation by MVF. I think it's a fantastic example of first-class data democratization. So yeah, definitely looking forward to it.
Perfect, thank you, Nathaniel. And I'll now pass on to Mark Jones from Snowflake.
Hi there, thank you for that. I'm Mark Jones. I'm an SC architect working for Snowflake. 25 years of the database industry, from MongoDB, NuoDB, Postgres, Oracle, and just loving my time in the power of Snowflake. Thank you.
Perfect. Thank you very much, Mark. And finally, Anwar Hanini from Looker.
Thank you very much, Tom. I work as a pre-sales for Looker. I was previously working in Microsoft Power BI, and I'd love to share some insights about Looker with our favorite partner, Fivetran and Snowflake.
Perfect. Thank you very much to our guest panelists today. And just to let you know, we do have a Q&A section. So there's a question section to the right-hand side of the screen. Any questions that the audience has throughout the webinar, just type them in there, and we'll get to the Q&A at the end to make sure those questions are answered. And finally, I guess we're extremely grateful to have Stephen Coyne, who's head of data analytics at MVF, with us today. I was actually lucky enough to sit in on this presentation not too long ago. It really is an incredible, success story when it comes to the modern data stack, not only in terms of new revenue opportunities uncovered, but just as Nate mentioned, the sheer level of data democratization that has been achieved at MVF over the last couple of years, and just empowering the business users. So it really is a credible achievement from Stephen and his team. And yeah, Stephen, thank you very much for being here, and I'll pass it on to you.
Brilliant, thank you. So yes, I'm Stephen Coyne, head of analytics at MVF. Been doing that for the past 2.5 years, and I've been working in data analytics for roughly around seven years. So MVF is a lead generation company. So we work with clients in various different sectors, healthcare, B2B, finance, to generate sales-ready leads for them. So we do this by running marketing campaigns across various different channels globally, and manage that through our leads platform, and then setting those on. So a lot of kind of challenges of a lot of marketing data, a lot of different touch points that our leads go through, both on our platforms, on our websites, but also on our client side. So lots of different types of data, which has led to kind of inherent challenges, which I'm going to talk about today. So for the agenda, I'm going to talk about the data challenge that we were faced with about 2.5 years ago, trying to find a single source of truth. All of our data was, scattered everywhere, no centralized place for it. How we went about building the solution, which was implementing a modern data stack with Fivetran, Snowflake, and Looker, and some of the impacts that we've had around democratizing data across our organization, how data insights drive revenue-making decisions every day. And then we're going to have a Q&A at the end. Cool. So 2.5 years ago, before we had a data team, before we had any data analytics infrastructure in place, we had a typical problem or challenge that many organizations have. You don't necessarily have we didn't have a centralized warehouse. All of our data was housed in Excel spreadsheets, in Google Sheets, even within marketing campaigns. Marketing teams were building their own Microsoft Access databases to manage the huge amounts of data that they had. And what we realized was we really need to invest in a coherent solution for this. And a common problem that we were facing that others face is we were using the same metrics, different teams were using the same metrics to mean different things. So we didn't have a consistent language of how we talked about metrics and how we talked about data. So we went about trying to find a solution to this. So this is a kind of illustration of what the modern data analytics infrastructure looks like, and different components. So on the left, you have various different sources. You may have APIs, marketing APIs, types of APIs you extract data. You may also have databases, MySQL or other. You might also have CSVs and more ad hoc data that's generated by people on the fly through Google Sheets or via emails. So all different types of varieties of data sources. Then you have some sort of process of data loading. You're extracting that data, making it consistent, normalizing it, and then loading it into a centralized data warehouse. And then in your data warehouse, obviously, it's where your data is stored and it's where it's processed for querying and analysis. And then you'll have a business intelligence tool that allows business users to access that data, to query it, to visualize it, and to analyze and build alerts off the back of that. And then you may also have data consumers, various sort of applications or machine learning algorithms that also access that data and use that for automation and other decision making. So this was the sort of analytics infrastructure. You'll probably see various different similar diagrams to this. This is kind of what we wanted to build, and we wanted to find solutions for each of these different areas. And we took the approach of trying to find best in the class technologies and tools that would meet our needs for each of these specific areas. We chose kind of going down the route of building a modular architecture, because that would give us the freedom to not only choose the best data loader on the market or the best data warehouse, but also the flexibility as our needs change, and we may need to have multiple tools for different needs, or as we grow, we might need to change tools completely. We weren't fully bought into one platform that did all of this. And often what we found in our research was if you find one tool that claims to do all of these things really well, they rarely do. There's always a compromise, and often the case is they don't do any of the parts sufficiently well. So we took each of these areas and looked to find solutions. So starting off with data loading. So I talked about, we have a lot of different marketing campaigns, 25 plus marketing campaigns, and that's growing. Every month our marketing teams are innovating and trying out new different channels. So we had a lot of different APIs that we needed to extract data from. And so we established a data team about 2.5 years ago. This comprised of data analysts and a couple data engineers. And it was the data engineers' responsibility to start to build out these data pipelines, extracting this data from these API, normalizing it, and writing that to our warehouse and sort of maintaining that. So they wrote the scripts themselves and managed the scheduling of these scripts and these pipelines through Airflow, which is an open source scheduling tool. But we inherently ran into a lot of problems during this process. So what we realized was that APIs are hard to maintain. They often change a lot. They can deprecate fields, deprecate reports quite frequently. So you have to really keep up to date with that. You also have to be able to manage when new fields come in or data changes. How are you going to handle that on your website? That can be a sort of complex task to ensure data consistency. The other kind of challenge we had was that we realized data engineers don't enjoy writing and maintaining data pipelines. It's not the most enjoyable part of their job, or it's not a fun, really interesting kind of part of their job. So it was quite hard to motivate engineers to continue to kind of focus on building out the next API and ensuring that, you know, we can kind of get value out of that. And then from the analyst perspective, we had a big dependency on our engineers. So if we were trying to do a piece of analysis or build a new report and we need a new field or a new report, we would have to make a request to engineers and it would go into their workflow and we would have to wait. So there was often a misalignment in terms of the workflows between analysts and engineers. They didn't always kind of work in sync. Often analysts would make a request to engineers would work on it, analysts would be waiting, and then once they receive the data, analysts would be working and engineers would be waiting. So we looked to find a kind of third-party solution that might make this process easier for analysts, that might give them more access, but also and automate the aspects that engineers didn't want to do. So we first started working with Stitch, which is a third-party tool for data loading. And Stitch enabled us to start to integrate all of our internal MySQL data. So we have a lot of internal data that we track as leads go through our various different platforms. And this kind of enabled analysts to, if they wanted a new table or a new field, they could easily connect it up through Stitch. So this kind of proved the case that giving analysts more autonomy in a platform that was secure and that was built by engineers was the way to go. So then we started to investigate the market for a more kind of enterprise level solution. So where Stitch didn't do everything we needed, for example, it didn't have all of the marketing source integrations that we wanted, various different APIs weren't supported. And we also wanted a platform that was really good and really transparent at alerting us and visualizing when data was lagging behind. So a common problem with APIs is, you know, they will have delays. There's going to be they're going to break every now and again, and this is the reality of working with third-party APIs. But we want a platform that would inform us and visualize that in a really easy way, so that we can be up to date and we can keep our business users up to date. So about 6 to 9 months ago, we moved to Fivetran, which was kind of like our enterprise solution for this. It covers all of our marketing sources, covers all of our database integrations. It's also now enabled us to integrate Google Sheets in a consistent and reliable way. It's also enabled us to do something quite new with our clients. So often we would receive CSVs back from our clients about lead data that we're sending them in terms of the quality that the leads we are sending them, that we use this information to optimize our marketing campaigns and improve the lead quality that we're sending them. And what Fivetran enabled us to do was to create a kind of email platform that any business can send a CSV on a regular basis to this Fivetran created email, and it would automatically sync that in Snowflake. And if they add new columns, it handles all that process and all that kind of sort of complexity. And this has enabled us to get going with really kind of integrating our clients' data into our data warehouse and building that into the service that we offer our clients. And so this has enabled really small clients that don't have a tech team, that don't have huge infrastructure to invest in working with our own API. They can just simply send a CSV to this email address. So that's been really great for us and for our clients. And how we start to think about our relationship now with Fivetran is we've kind of outsourced our data ingestion needs. So we've got this kind of huge data engineering team, which is essentially Fivetran, that handles all of our data connections. And if there's any issues, they've got great support. They respond really quickly. And if we have new marketing sources or new API needs, which I'm sure we will, we can work with them on building those connectors. And in terms of the time and the impact that it's had, so approximately a new data integration from our side would take roughly around 4 to 6 weeks to complete. But now with Fivetran, it will take an analyst under a minute, few sort of clicks to implement, and then it will do a historical sync of the data. And that can vary, but it can take up to a week, a lot of data. But in the meantime, they're not sitting there, working on it. They're off doing something else. So moving on to data warehousing. So I talked about previously about the Google Sheets and the Excel and CSVs, and essentially this was our data warehousing, how it was done before we actually invested in building infrastructure. And another element was MySQL. So we had business users that taught themselves a bit of SQL that were running queries on our production databases, which is obviously a bit worrying, quite scary, and there have been like horror stories of how that's gone wrong. So, and a good interesting point to make is that the culture of your culture of how you use data in your business is going to be heavily influenced by the tools you use. So we're really data-driven business. We want to use data in a smart way. We want to use really granular data to optimize our ads and our marketing campaigns. But there's a limitation in what you can do in Excel and Google Sheets with how granular and how much data you can analyze. So as a result, we were not able to look at year-on-year trends at a granular level. What marketing teams were doing was looking at their ads and their campaigns performance, but they were very focused on day-on-day performance, week-on-week performance. And this meant that we were missing out on deeper kind of insights around, well, if we saw fluctuations, were they seasonal fluctuations that we expect? And it was leading to kind of very reactive approach to our analysis. And of course, because they weren't centralized, one person would pull a report and another person would pull a report, and the reports, same reports wouldn't align in terms of numbers because they were pulled at different points. There was no consistency in terms of that. So we look to kind of invest in our data warehousing and invest in a sort of database that's built for analytics, so a columnar-based data warehouse. And so about 2.5 years ago, we moved to Amazon Redshift. A lot of our infrastructure was already on Amazon AWS, so it made sense at the time. And the big kind of step up from spreadsheets to Redshift was that we can now look at process kind of years worth of data in under a minute, when previously like finance team putting together a year-on-year kind of finance report would take them up to 20 hours of active work, pulling individual reports, pulling it month by month, and then trying to stitch it together. This could now be run in a minute. And this opened up a whole new opportunity of how we thought about data, how we thought more in terms of long-term, more in terms of kind of deeper analysis, more interesting questions that we could ask. So Redshift kind of got us so far, and after about a year, we started to have sort of TV programs. So we like to think of ourselves as a data-driven company, and when we implemented Looker, we went for giving as much people as much access to the data as they can, because we don't want, as a data team, we don't want to be a roadblock in terms of the analysis that they can do, and we want to enable everyone to be an analyst within our business. And so we have around 90% of our Looker users are explorers, meaning that they can build new reports, build new dashboards, essentially build any kind of query that they want. So we've got a lot of people, roughly 400 people running queries at any given time on our data warehouse. And that's just individual queries. But when they have dashboards, a dashboard is made up of 10, 15, maybe 20 queries. And so what we were seeing was that during like 9 till 11 in the sort of peak period of our warehouse usage, people were coming in the morning, running their dashboards, opening up a bunch of tabs, and that was just overloading Redshift, and it wasn't able to handle that. So we were seeing this concurrency problem where when you have multiple queries running at once, Redshift wasn't able to process them, and so basically queued them. And so we were seeing a really bad experience for our users and just having to wait minutes, sometimes 10 minutes, but the query wasn't actually running, it was just in the queue. So there were kind of problems with that, and there was also challenges from the engineering side in terms of there was quite a bit of maintenance work with Amazon Redshift in terms of vacuuming the data and ensuring that to keep it performant, you needed to vacuum it on a regular basis, which means kind of cleaning out the deleted data. And so those kind of processes had to be maintained and had to be scheduled outside of work hours to ensure it didn't affect other users. So to solve the concurrency problem, we looked at different warehouses, different kind of alternative solutions, and by far the winner was Snowflake. So the real reason that Snowflake could handle this problem was that they separate processing from storage so that you can scale each of those independently. So as our users were just scaling, as a result of our business, we were just hiring new people every month, and we are onboarding then new users to Looker. We were able to scale Snowflake accordingly, and as a result, you can also scale throughout the day. So in that peak period in the morning when everyone's coming on and running their dashboards and hitting the warehouse hard, Snowflake then can auto scale up and allocate the resources needed to do that. Then in the evening or in the weekend when no one's using it, it scales back down and we're not actually paying for it. So you're only paying as you use it. So that was a really kind of efficient way, both in terms of delivering a great experience for our users to get them the performance they need, but also in terms of cost, far more cost effective to only pay when you use it. So that saw, by switching over and not doing any kind of other query optimizations, we saw an 87% reduction in our average query time, and we eliminated queued queries. Now that doesn't really happen. And from the engineering perspective, the transition from Redshift SQL to Snowflake SQL was very smooth. There was pretty much the same syntax, few date functions that are slightly different. That was pretty smooth. But also in terms of maintenance, we've had Snowflake about 1.5 years now, and our engineers have done nothing on terms of maintenance. So they love it. So data modeling. So once you have your data in your data warehouse, it's not necessarily structured in the optimal way for your BI tool or for data analysis. So data modeling is the process of taking that data, cleaning it, maybe combining tables, multiple tables into one table, building sort of denormalized tables, or building fact and dimension tables. And again, when we started off, a lot of our processes were a mishmash of data engineers running scripts that were managed in Airflow. Analysts were building their own transformations using Looker, taking advantage of Looker's PDTs. And again, we ran into multiple problems. So with the PDTs, we over-relied on the feature of PDTs. And PDTs are great for doing kind of small things or prototyping new tables, but you don't want to build your whole production data transformations on PDTs. You can't do sort of incremental updates, and they're not fully flexible for that. And again, with data engineers managing transformations, you have that problem where access and flexibility for data analysts. So about 4 or 5 months ago, we started using DBT. So DBT is an open source tool that allows you to do your data transformations. So it means that all of our raw tables will be transformed by DBT into a kind of clean transformed table, and then our BI tool will be pointed only at the clean data. And so some of the benefits of DBT, it's SQL based, meaning that analysts can use it, but it's built by engineers and data engineers. So again, similar to kind of Fivetran, it has the confidence from our engineers that it's built in a robust way, but it has the flexibility of a platform that analysts can use. Another really interesting aspect is it has automated data tests. So again, something that we've not done, and until recently, and we didn't start doing this. Yeah, we didn't start doing this until recently. Was testing our data. So that involves two things. It's testing the data that gets written into your data warehouse, ensuring that the data types are consistent, ensuring that the data is fresh as you expect it, and ensuring that there's no new columns or what have you. And then there's tests on your models. So if you build new models in Looker or you do transformations, you want to ensure that the assumptions that you have when you build those models are correct. So this is a common practice in software engineering called test-driven development, and these kind of processes and these methodologies are coming into the data analytics world and slowly kind of being introduced. And DBT enables you to write your own tests, and they have, like, you can test for unique primary keys, or you can write really bespoke tests. You don't expect this revenue value to be over $1 million for a given day or something like that. Another thing where we've been pretty poor at is documentation. Everybody likes to write documentation, and the problem with kind of having documentation outside of your code is that as soon as you update your code, your documentation is out of date. So you kind of have to maintain two things at once. But with DBT, documentation is built into the code in a similar way that you build your documentation into your LookML in Looker. And I think that's kind of the best place for documentation to sit. Obviously, that's not an excuse for not documenting your processes and what have you, but for more specific models and what have you, it all should ideally sit within your code. And you can also sort of schedule this and automate tasks through macros, which are essentially like Python functions. And so from the beginning, we've been using Looker as our BI solution. So before Looker, to summarize again, like, we had no central source of truth. That was something we really wanted to solve. We wanted Looker to be the place that people go to for data, and that it would be reliable and consistent. In terms of the analyst workflow, we prior to forming a data team and working with Looker, we had analysts across the business that didn't communicate, and they would solve one-off ad hoc problems. So if someone wanted a particular report, they would write a query for that report and it would be done. It wouldn't be version controlled, and it would be wouldn't follow kind of best practices or any sort of coding standards. And it was a kind of one-to-one relationship. For every one report the business wanted, there was one query. Data, so I talked about previously how you're limited, or how your data culture is influenced by the tools that you use. And this was the same in terms of how we visualize data. So all of our data was in spreadsheets, and all our reporting was done in spreadsheets. And as a result, our data was visualized predominantly in tables. And tables are good for reading of data, but they're not good for spotting trends easily. And so we were kind of missing out on that kind of opportunity. And then our reporting was very reactive. So if we saw a top level fluctuation or drop in performance, we would have to kind of go dig into the data and react and try to find out where that problem was and why it was there, rather than having that problem or those insights surface to us a lot sooner. So that was kind of like a lot of wasted time. And so with Looker, we've democratized data analysis to now 90% of our business. So 90% are explorers answering their own questions using Looker, and they don't require technical training or SQL skills. From an analyst perspective, we're now building reusable, flexible models rather than singular queries. And what that means is that rather than answering one particular question that someone in the business has with one solution, we are actually taking a step back and looking at our data and defining how our data joins together, what are different measures and metrics that we want to report on, and building a model that is future-proof. So the model, one model will not answer one question. It can ask many questions today, but it could also ask many questions in the future. So this makes our work as analysts a lot more productive, a lot more flexible, a lot more interesting, and yeah, it's a lot more useful then for the business users. It allows that democratization because they don't have to come to us for every particular question they have. They can actually go ahead and answer it themselves. And a lot of the software engineering principles that I talked about are kind of baked into how the kind of philosophy of how you use Looker. So it's version controlled. There's linting, meaning you can ensure that that the code is consistent with how you write it. So when you have multiple analysts, you can have a linter that checks that the analysts are writing the code in the same kind of way. LookerML, which is the modeling language underneath Looker, follows dry principles, which is do not repeat yourself, which is another software engineering principle. So LookerML has aspects of object-oriented programming, meaning you define objects, dimensions, or measures, and then you can reference them in multiple places rather than repeating the same code in multiple places. So you define things in one place and can reference that multiple times. And then we've moved to a far more proactive analysis through alerting and utilizing Looker's alerts into Slack, our communication platform. So rather than discovering late that there's a problem and then trying to work back and find it, we actually have fluctuations and changes in our campaigns and keywords and ads surface to us through alerts and surface to the actual people that can take action on them. So in conclusion, this was the sort of modern data stack that we built, and we built a sort of modular data stack where we've selected the best tools for the job in each case. So Fivetran handles all of our data ingestion needs, Snowflake handles warehousing, Looker handles exploration and visualization, and DBT handles our transformations and our testing and documentation. So I want to talk about a few examples of how we use this data to drive impact in our business through improving revenue. So the challenge we have in our business, we run marketing campaigns globally and we generate leads for our clients. But often we generate leads that we can't sell to our clients. So there's two scenarios. One scenario is we've generated leads that are of poor quality, and we disqualify those leads. But in some cases we have high quality leads, but no clients available to buy them. So in that scenario, the leads that we have are looking to purchase a product that we cannot actually sell at that point in time. So we've spent money to acquire these leads, and we can't sell them. So it's kind of wasted spend. And then at a future point in time, a client may come on onto our platform looking to buy leads that meet those exact needs. And we have those leads somewhere back in our database, but we're unable to connect them. So what one of the teams in our qualification team, our call center, basically saw this problem and started to kind of visualize it in Looker. So what they did was they visualized the number of unsold leads that were of high quality that were available and checked that against clients that were now available in a given point of time. So these were historical leads and they were looking at the current state of available clients and subscriptions and trying to match that. Can they now sell these leads on? And so they started to do this and they started to sell these leads, these unsold leads, and were able to rescue revenue. We call this rescuing revenue because this revenue was kind of left on the table and untouched, and approximately 250 to 600K of revenue a month over a 3 or 4 month period. So here's an example of one of the visualizations. This is kind of percentage of leads. So the red is the percentage that we disqualified because either they were low quality or we were unable to sell them. And then as you can see, when the purple emerges, this was the recategorization of those leads into unsold leads. So this is now actually seeing, well, what is the opportunity that we have of those disqualified leads to sell those on, which makes up a huge proportion of those disqualified leads. And then what they were able to do then is look that up against the clients that are available and start to sell them. And within this dashboard that they were using, they also had the figures on in terms of how much revenue they had rescued, so they could sort of see and be motivated by the impact they were having. So this was a small team, 2 or 3 people, that generated a huge amount of revenue using data in a smart way and not doing anything technical or from the back end. They were using, you know, the front end of Looker and visualizing all the data that was there, but finding the discovery. And as a result, this built the business case for investing engineering resource to automate this platform. So now this platform is automated from end to end, and it constantly checks when a new client comes available. Historically, do we have leads already in our bank that we can sell? So a few additional use cases. Our product teams use Jira to manage their tickets. And we now import all of our Jira data with Fivetran into Snowflake, and it is visualized in Looker. And we have this dashboard that sits on a TV monitor as we enter the tech room. This monitors throughput and cycle time and defect rate, and it becomes kind of a central point in the morning for the product teams to have a scrum around and to talk about how the performance is going. In marketing, we have, like I said, various different marketing channels, and we have different dashboards for the different channels that go from really top level GP performance of campaigns to really granular ad performance. And so they're able to follow, they have alerts set up that identify anomalies or where we see either performance going down or performance going up. And then they follow a sort of decision tree basis of dashboards that identifies which metrics have caused the said kind of increase or decrease, and they follow along that workflow. So we're really kind of investing a lot in trying to automate, help automate sort of the marketing process. And then sales, where we really want to have a data-driven sales team, and so they have a lot of their pipeline visualized in Looker, and we're also working towards building a client health dashboard that kind of predict the likelihood a client is to churn. And that's it. Thank you. Any questions?
Perfect. Stephen, thank you very much. Really, really great and insightful presentation. And I think a lot of people probably resonate where you and MVF came from and where the journey started, I guess. But I'm going to fly ahead into the Q&A because we're running out of time. So I think we have a question from Kevin for probably Fivetran, Nate maybe, and MVF. What are you loading from Facebook? So I guess what data are you loading from Facebook? Maybe Steve, if you want to go ahead, and then Nate.
So we're pretty much loading everything that's available in terms of ad data. So yeah, granular ad sets and audience kind of data mainly.
Perfect.
Yeah, and just from the Fivetran side, the type of data we can load from Facebook is a number of different levels. There's the Facebook Ad Insights API, which has it's the reporting API, all of the fields breakdowns, action breakdowns. Then we have the Ad Account API for Facebook that has all of the metadata on the different campaigns that you've written. And we also have the social or pages connector for Facebook that is currently in security review with Facebook, but it's fully built. So pretty soon all of the shares and the likes and all that social data will be available as well.
Perfect, thanks. I should add, if there are any other questions that people have afterwards, you can always email any of the email addresses here or any of us. Just another question here from Avi, I think, is what is the difference between Fivetran and DBT? And both seem to be addressing data transformations and data loading. I guess that's again Fivetran, and maybe Stephen, you'd like to jump in as well. So we can go ahead with Nate, maybe.
Sure. The way Fivetran works is we connect to the different data sources for APIs, let's say, and then we deliver a pre-designed schema that is mostly designed for analysts to be able to work directly on top of that schema. But there are scenarios in which you may need to join data from different tables, or you may, for instance, be syncing a database that has complex data, and you need to, within Snowflake, create additional tables that are kind of pre-joining the data so that when you connect Looker, those queries are more efficient. And actually, just 2 weeks ago, Fivetran launched a SQL-based post-transformation layer in a private beta exclusively for Snowflake, so that you can do these type of SQL transformations directly from within Fivetran for the post-load. But I think maybe Stephen can speak further to dbt and the use cases that they've had.
Yeah. I think you explained it well. dbt and Fivetran do very different things. So dbt won't do any extraction of the data from APIs, and it doesn't do the loading. It just, once it's been loaded, if you need to remodel it, create new tables, fact and dimension tables, you can do that. And you can create like tests and stuff. So it's really post once the data's been loaded, whereas Fivetran loads the data, and now can also transform the data and restructure data. So I see they do quite different things.
Perfect, thank you. And this is for Snowflake, definitely. I think you covered it a little bit, Stephen, but maybe Mark could help us out. How does Snowflake handle concurrency?
Yeah, thank you for that. Yeah, it was handled in the conversation, but we handle concurrency by automatically scaling horizontally. So we have a notion of what we call virtual warehouses. And when Snowflake detects queues, you can have it configured so that automatically we will horizontally scale to put more compute power behind your Snowflake instance for you.
Perfect, thank you. And I know we're conscious of time here, but I think even MVF and how good you were in bringing Looker in. Is there any types of usage of Looker beyond exploration and visualization? Anur, I think you can probably help us out there.
Yeah, so I think some of the use cases Stephen has covered. Mainly, what we're trying to position Looker now is being very beyond the BI tool, that can do all the BI application that you're familiar with. So it also help you set up alerting, for example, or integrate Looker into existing platforms or existing workflows to integrate with applications. So this is really the main use cases that we have seen in Looker, and I think our API approach help us to achieve that very smoothly.
Okay, thank you, Anur. And I think we have another question from Dan. What is the added value of Airflow in combination with Fivetran? So I guess, Stephen, that's probably you.
So Airflow would be managing. Airflow is merely just a scheduler of scripts. So those scripts could be doing anything. They could be managing extracting data from an API, or they could be managing your own transformations. So we currently still have it for a sort of legacy stuff. But there may be unique cases where we need to run a specific Python script that builds a machine learning model or does some kind of transformation or whatever, and Airflow enables us to manage that and schedule that. So it's kind of like it's a tool for a very specific thing for scaling, and it's useful to have.
Perfect, thank you. And we have another couple of questions coming in. Will Fivetran work with Oracle database as the warehouse? I guess Nate.
Yeah, great question. Currently, so there are many different types of oracles as databases that we support as a source, and we're building out more and more of that support on the source side. In terms of it as a destination, I don't think that's on the current roadmap. Yeah, it may. Yeah, I don't see. It may come on the roadmap, but frankly, it would probably need to have the type of performance that would compete with Snowflake, and they're quite far in advance. So, but we do definitely have it prioritized as supporting it as a source.
Great, thank you. And we've got one more question just from Steve. How is the Snowflake auto scaling limited or managed? So Mark, I guess if you could jump in on that one. Do we have?
Yep, sorry, thank you. Yeah, so how it's limited, you can limit it through what you can say you want to scale horizontally from, let's say, 1 to 5 virtual warehouses, we call them, and when the queues die, they will scale down again. However, if you want to limit as well, what you can do is you can put some resource monitoring on to get alerts as to what to do when you reach a certain capacity. So, for example, you may be running 5 warehouses for a whole hour of a certain size, and that would cause you to go over a certain threshold. You can be alerted, or you can immediately shut one of those down.
Perfect. Thank you, Mark. And I know we're running out of time, but we've just got another one come in there. How is the Snowflake pricing work? So that definitely, Mark, this for you. Do we pay for the data transfer between the storage and the computing nodes?
Once your data is into Snowflake, you pay Snowflake for what we call a credit. And that credit is a consumption of compute power. So when you're actually querying data and it's going to disk to get the data, we store the data on our storage behind Snowflake. So if it's on Amazon, it'll be on S3. If it's on Microsoft, it'll be Blob storage. And we just pass on whatever the cost of storage is. So not the transfer from disk to compute, just the cost of storage is all we pass on to you as far as storage goes. Perfect.
Thank you very much, Mark, and thank you very much to Anor and Nathaniel, our experts. And finally, big thank you to Stephen. Really enjoyed the presentation. That was very insightful and very valuable, I hope, for everyone going forward. I think we've run out of time, so we're going to cut it short here now, let it go now. And we'll follow up with any questions that we didn't get to, and we'll also send on the recording and the slides over the next couple of days. So thank you again, everyone, for joining, and I hope you have a great day.